Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about what are the various definitions and terminologies in communication of data. So, what are the various principles of data presentation? So, that is the first one. So, for that, the principle should be the data should be arranged in such a way that it should be able to create some interest in reader, and the data should be sufficiently concise without losing its important details. And data should be presented in simple form to enable the reader for the quick impressions and to draw some conclusions directly, indirectly, and should also facilitate further statistical analysis and should define the problem and suggest the solution. So the principles for presentation is that whatever the data we're presenting that should able to create some interest in reader, and the data what we're presenting that should be sufficiently concise so without losing its important details, and it should also enable the quick impressions and how to draw some conclusions directly and indirectly, and it should also facilitate further statistical analysis and should able to define the problem and suggest the solution. And some of the methods were available for presenting the data. So the first step in the data analysis is the presenting the data. So it should be easy way to understood. So for that we are going to have two types of methods that are available. So first one is tabulation and second one is charts and then diagram. So these two methods are very easily whatever the data we are going to be presented, and if you have the text in the form of what we have the data, and that one should be presented either in the form of tables, or you can able to present in the form of diagrams itself. And next question is that what are the various charts and diagrams for presenting the data? So for that we are going to have some of the diagrams like bar diagram, histogram, frequency polygon, cumulative frequency curve, scatter diagram, line diagram, and pie diagram. So these are the various charts and diagrams we're going to be uh, have for presenting this data. And so again, this bar diagram will be of two types, like simple bar, component bar, and stacked bar, like this. And histogram, frequency polygon, cumulative frequency curve, these all will be under subcategory. And scatter diagram, line diagram, pie diagram, so these three will be under subcategories. So next question is that what is the visual way to show the data? So for this, so the data visualization is the graphical presentation of the data by using visual elements like charts, graphs, and maps, and data visualization tools able to provide a easy way to see how the can able to understand the trends and then outliers and patterns in the data. So the visualization should be graphical presentation of the information as well as the data. So by using the elements like charts, graphs, and maps, so the data should be a data visualization tool. It should be an easable way to see how we're going to understand the trends, outlier patterns in data. So what are the various three methods of data presentation is another question. So for that we are going to have three types of presentation. So first one is that textual and descriptive presentation, table presentation, and then diagrammatic presentation. So initially, the text what we're going to be obtained from multiple sources should be this text in the form of text only. So it is difficult to understand. So what we are going to do, so this data is going to be analyzed and then have to be present in the form of a table. So it should be a simple, easy to understand the data, and then we can also make the comparison easily. And another form is the diagrammatic representation. So in diagrammatic representation, can able to represent the text diagram text in the form of graphs, or you can bar graph and then pie chart like this, and histogram like this. It should be the difficult way of create a diagrammatic representation for presenting that. And what are the five methods of data presentation? So some of the popular ways of presenting the data may be include line graph, um, column chart, and then box plot, and then vertical bar, scatter plot. So these are some of the various diagrams we have for presenting the data. The next question is that why the visual presentations are important in presenting the data. So for this, so the data visualization able to give the clear idea of what the information means by giving it visual constant through maps and graphs. So this makes the data more natural for human mind and to comprehend, and therefore it makes it easier to identify the trends, patterns, and outliers within the large data set. So so the data visualization able to give the clear idea what the information means by giving it visual context to maps and graphs. And this makes the data should be more natural for human mind and therefore makes it easier to identify the trends, patterns and outliers with large data sets. And next one, what are the five formats for visual display of the data? So for that, we are going to have column chart. So this is the one of the most common way of data visualization tool, and then bar graph, and then stack bar, line graph, and then dual axis chart, Nico chart, pie chart, and scatter plot. So these are the various five formats of visual display of the data. So the column chart should be where you can able to present the form of bar graph only, and then stack bar chart, bar graph, line graph, and then visual axis chart, Nico chart, pie chart, and scatter plot. So what are the key five principles of data visualization? So some of the five principles of data visualization will be determine the best visual, balance the design, focus on key areas, keep it simple, and then incorporate interactivity and then use patterns. These are the some of the simple patterns that are going to be have. So the key principles for effective data visualization will be able to determine the best visual, balance the design, focus on key areas, keep it simple, incorporate interactivity, and use patterns. So these are the various key principles. So what we have to be followed for the effective data visualization. And explain the significance of tabulation is the under question. So here the data presentation will be of two types. So you can able to present the data in the form of a table form, or you can able to present the form of visual form. So the visual representation should be graphical representation and diagrammatic representation. So here the table representation means where you can able to present the data in the form of table, and visual representation means where you have to present the data in the form of various graphs and all. So that should be the graphical representation and diagrammatic representation like this. So what are the principles what we have to be followed for presentation of the data? So the data should be presented in simple form and should be able to create some interest in reader where you can able to uh, concise the data without losing its important details, and should also facilitate the further statistical analysis, and we can able to define the problem and should be able to suggest the solutions. So these are the three principles what we have to be followed for presentation. So the data should be presented in simple form, and we have to be create an interesting reader should be able to concise, so without losing its important details, and then should also facilitate further statistical analysis, and how to define the problem and should be able to suggest the solution as well. So the tabulation, so it should be a systematic and logical arrangement of classified data either in rows and columns. So initially we have our data. So this data is going to be classified into different types, and then this thing should be presented in the form of table. That thing should be called as the tabulation. So this should be the systematic arrangement of logical arrangement of classified data either in the form of rows and then columns. So by seeing this example, so sports, so snooker, tennis, gymnastics, swimming, track. So these are the various codes, and how many number of people are interested in doing this activity. So for this snooker, there's some of people, 1 or 6 people are interested in tennis, 45 people are interested in gymnastics, 54, like this. So what is the significance of tabulation? So this thing is, so it should be able to simplify the complex data, and unnecessary details and repetition of the data should be avoided in the tabulation, and it should also facilitate comparison, and then it should also give the identity to the data, and should also reveal the pattern within figures which cannot be seen in narrative form. So the main significance of this tabulation will be, so whatever the data we have, the complex data that should be simplified. Then second one is that unnecessary details and repetitions of data should be avoided. It should be able to facilitate comparison, should be use the identity with the data, and it should also reveal the pattern of the figures which cannot be seen in narrative. So what are the different types of tables for data presentation? Uh, so the types of tables will be basis of purpose and basis of content. So based on purpose means reference table and then text table, and based on the content means simple and then complex tables we have. So again, this complex tables is further divided into types like double tables, triple tables, and multiple tables. So normally the tables what we have that should be presented in two types. So first one is based on purpose, and the other one is based on the content. So if the purpose is considered, then the reference table and text table are the two types, and then if we are going to consider the content, so then the tables will be simple and complex one. So again, there should be further categories in complex table like double table, triple table, and then multiple tables. So explain the presentations of the data using graphs. First one is graphs and diagrams. So graph means histogram. So and then frequency curve, frequency polygon, obtuse, and line graphs. So these are the different types of graphs what we have. So histogram, there should be no graph space between the bars, then it should be a histogram. And if I'm going to join the points of this midpoint of all this, let me draw clearly histogram. So for the histogram, so I have to be draw a histogram like this. So we should not maintain any space between each and every bar, then it should be an histogram. And in this, if I'm going to join all the midpoints of these rectangle bars with a straight line, then it should be called as frequency polygon. And if I'm going to join all the lines with a smooth curve, then it should be called as a frequency curve. And obtuse and line graph is the another type of presentations. And bar diagrams. So again, these bar diagrams we have simple bar, multiple bar, component bar, percentage bar, and deviation bar. And pie diagram also is under. So what are the advantages of this? So it should be very attractive one and should be able to use the bars eye view of the data and should be able to easily understood by common man, and they should also facilitate the comparison of various characteristics, and impression can be created by them in a long lasting, and then the theorem results of statistics can be visualized in the form of graphs. Next one. So what are the different techniques of presentations of data using graphs? So for this, just now what I said, see histogram. So what is a histogram? So it should be represented by set of rectangular bars, and the variables is going to take along the x-axis and frequency is going to take along the y-axis. And note that the set of rectangle bars so often use the histogram, and the total area of rectangles in histogram represent the total frequency. And if the frequency distribution has inclusive class interval, then they should be converted into exclusive time. So the total area of rectangles in histogram represent the total frequency, and if the frequency has an inclusive class intervals, then they should be converted into exclusive time. So using histogram, so we are going to construct the data. So suppose I'm going to have a table like height and the frequencies like this. So in between for 145 to 50, that is the frequency of people, two frequencies, and in between 150 and 55, 5, and 155 to 169. So these are the different types of data we have, and in this we have to construct this. So we have to be set the interval 145 to 150, 150 to 155, 155 to 160, 160 to 165, and 165 to 170, like this. So the frequency is true, so we have to mark with the frequency, and similarly 151 it should be fine, so mark the other thing, and 160, 159 it should be. So like this, you have to construct all the bars in the histogram without any gaps. And the mode of distribution can be obtained from the histogram itself. So the mode values should be the middle of this histogram, that should be considered as mode value. And frequency curve. So how the frequency curve can be obtained? So the variables is going to be taken along the x-axis, and frequencies are going to be taken along the y-axis, and these frequencies are going to be plotted against the class mid values, and these points are going to be joined by a smooth curve. So the curve what we obtain it should be a frequency curve, and the total area under the frequency curve represents the total frequency. So here, so the variables, so if I'm going to have a graph like this, so x and y, and variables I'm going to take on this 2, 4, 6, 8, and the frequencies are going to be taken along the y-axis. So suppose if I have a constructed histogram like this, so this is the sample histogram what we constructed. So in this we have to construct the frequency curve. So if I'm going to join all the midpoints of this curve, so frequency curve, right? So after removing this bars, so the curve what we obtained, that should be the frequency curve. So here, so x-axis variables are going to take, and y-axis frequencies are going to be considered, and the total area and frequency represents the total frequency. So see this example under example. So the marks obtained is going to be taken on the x-axis and number of students on the y-axis. After constructing the histogram, so we have to join all the midpoints of all these histogram midpoints. So the curve what we can able to obtain, that should be the frequency curve. The next one is frequency polygon. So here also the same. So the variables are going to constrain x-axis and frequencies along the y-axis, and the frequencies are going to be plotted against the class mid values, and these points are going to be straight line. The figures so obtained should be considered a frequency polygon, and the total area under the frequency represents the total frequency. So what is this frequency? How we're going to construct it? So in between the range, so 0, 5,000 to 10,000, and 10,000, 15, 15 to 20. So the number of workers, how many people are there with the salary. So for this, we have to be initially plot this dots. So initially, I will be in between 50 and then 5,000 and 10,000, 10,000 to 15,000. between 15 to 20, in between 25 to 20 and 25 to 30. And this is the initial histogram what I constructed. So if I join all these midpoints of this rectangle bar, the histogram, so this is the histogram initially what we constructed. So after joining all the midpoints of this histogram, so the curved line what we obtain, so if the points are going to join with the line, so the curved line what we can able to obtain, that should be the frequency polygon after removing all this rectangle bars. And next one is that OGU. So OGU is nothing but cumulative frequency curve. So the OGUs is going to be a smooth graph which is going with a cumulative frequency plotted along the variables. And these class limits are going to be taken on x and y axis, and class frequency is going to be taken on the y axis. So these are going to have two types of OGUs. So first one is the less than OGU curve and greater than OGU curve. So what is the less than OGU or less than cumulative frequency curve or greater than cumulative frequency curve? So based on these values, we can able to decide whether it should be what type of OGU. It should be a less than OGU or it should be. So in less than OGU curve, the variables that is going to take in on x-axis and cumulative frequency is going to take on y-axis. Then the points are going to be joined by the smooth curve, and the greater than cumulative frequency curve is taken on x-axis, and then cumulative frequency are going to be taken on the y-axis, and these points are joined by a smooth line. Then the resulting graph should be greater than. So two types of OGUs are drawn in a single plane. So if I'm going to have a curve like this, so this one should be considered as less than OGU, and this one should be considered OGU greater than OGU. So in less than OGU means where we can able to obtain the line from lesser to higher values, and more than OGU means we're going to obtain the value from higher to lower values. So whenever the two OGU curves are joined, so the midpoint of the two intersections, that is positive OGU and the negative OGU, so they should be less than OGU and they should be greater than OGU. So the the intersection of the two lines midpoint should be considered as the median. Our next one is that line graph. So that should be time series graph. So the line graph are going to be used to display the comparison between the two variables which are plotted on x and y axis. And this x-axis represents the measures of time, while the y-axis represents the percentage of a quantity. So they are going to organize the present data in a clear manner to show the relation between them. And the line graph displays a change in direction, and it shows the trend of event occurring over a period of time to know whether it is an increase or it may be a decrease. So the line graph are going to be used to display the comparison between the two variables, so which are plotted on x and y axis. And x axis is going to represent the measures of time, whereas y axis is going to represent a percentage of measures of quantity. So here they are going to organize and present the data in clear manner to show the relationship between the data, and the line graph displays a change in direction, and it shows the trend of event occurring over a period of time to know whether it is an increased or decreased. For this, we're going to use a line graph, or it may be called as a time series graph. So in time series graph, what we can able to say that. So if I'm going to duration of admission and then foreign hit if I want to write it. So after marking all the points, and if the points are going to join with a straight line, so the line graph is going to be obtained, or the time series graph is going to be obtained. So this is the underview. So the retail of petrol and diesel along with the price of crude oil. And next one is that, so what are the different techniques of presentation of data using diagrams? So we are going to have different types of diagrams like pie diagram or sector diagram. So normally this one is going to be used for presenting the discrete data of qualitative characteristics such as blood groups, age factor, age group, sex group, and the causes of various mortality and social group in the population. And the frequencies of the groups are going to be shown in circle, and the degrees of angle denote the frequency and area of the sector. So it gives the comparative difference at glance, and the size of each angle is going to be calculated by multiplying the frequency. And the size of each angle should be calculated as frequency by total frequency to 360 degrees. So representing the discrete data of qualitative characteristics such as blood groups and carriage factor, age group, and all. So the frequencies are going to be plotted on a circle, and degrees are going to denote the area set, which gives the comparative difference between the glance, and the size of the angle is going to be calculated by frequency by total frequency to 360 degrees. So for the how we're going to construct this pi diagram means, so take a circle and then draw a circle first and find the center point of the circle and draw the radius. So by making use of this protractor, you have to be known the angle, how much angle you have to keep it out. Now for this, for tuition fee it should be 62%, for room 17, road, books and then transportation 3 and 8. So let's say the example how we're going to construct this pi diagram. So first blue is there, and for this you have to calculate the frequency by total frequency, that is 54 degrees. I'm going to angle degrees is getting, and 54, so 54 degrees you have to make it. The next one is 90, and similarly next one green, that should be 36 degrees. The next one red, 45 degrees. The next one purple, 72 degrees. 63 degrees. So like this we have to be construct the pi diagram in different values. So let's say other example, like we're going to have items and expenditure and measurement degree as we have. So based on that we have to make an angle. So by making use of the protractor we have to construct this. And next one is bar diagram or bar chart. So the bar diagram consists of a series of rectangle bars of equal width, and then the bars are going to be stand on common baseline with equal gap between one bar and another bar. And you can able to construct the bar either horizontally or vertically. And these bars are going to be constructed in such a way that the lengths are going to be proportional to the magnitude. There are different types of graphs like simple bar. So we have been able to represent items in a single characteristics, and these items are going to be represented of rectangle bars are equal width, and the height is going to be proportional to the magnitude. The bars are going to be drawn on common baseline with equal distance between them. They should be of different colors. So we are going to have so the number of bicycles and the number of buses in a school transportation to construct in the form of bar diagram. The next one is number of deaths. So this is another example of constructing the bar diagram. And next one is subdivided stack proportional bar diagram. So in this one, the data is going to have the items, so whose magnitude is going to be two or more components, and these items are going to be represented by rectangle bars of equal width, and the height is going to be proportional with the magnitude. So the bars are going to be divided into subdivisions. In height represent the components, and order to distinguish between the components from one to another. So the different shades are going to be applied, and the component bars are going to be drawn whenever we are going to comparison is going to be constrained. So here the bar is going to be divided into different sections. So in number of students that is studying from BSc, how many number of girls and how many number of boys. So similarly, how many number of boys and girls in second BSc. So like this, we can able to map it. And percentage bar diagram means here the height of each bar should be mapped with the 100%, and these bars are further divided into different segments, which is going to present the different information. So your blue represents a dance, and TV, maroon, and yellow is for sports. So how much percentage of people are interested in different hobbies? We have to present that should be called as a percentage bar diagram. So normally this one is going to represent the item whose magnitude of having two or more components, and the comparison of the components going to be exposed in terms, and the totals are going to be presented by equal width and equal to height. So this is another example. So we should be mapped with the 100%. An entire bar diagram, uh, the entire bar is going to be segregated into different percentages. So like the percentage of fats is to this, and percentage of protein, and percentage of carbohydrate. So same thing I can able to represent in each community also. And next one is multiple bar diagram. So your multiple bar diagram. So when I'm going to show the relationship, I'm going to make the comparison, then multiple bar diagram is going to be suggestible one. So here the rectangular bars of equal width with height are proportional to the value drawn, and the bars corresponding to the same unit are going to be placed together and adjacent to one another. The diagram is going to be shaded properly, and has an index is going to be provided. So here the multiple diagram is going to be constructed where the diagram is going to be shaded properly and index is provided, and the bars corresponding to the same unit is going to be placed together to adjacent to one another, and the set of rectangular bars of equal width and height proportional to the value is going to be constructed. So in this one, so the blue is going to be indicate sales by division. So north, south, east, and west. So what should be the sales in different directions of India? I want to know. Similarly, I want to know in 2010 and 2011 in southern portions and northern portions of India. And should we can also compare easily. So this is another example. So how many number of students are studying first BSc, second BSc, with the difference of boys and girls. The red color is going to indicate the boys and green color is going to indicate the girls. And deviation bar diagram. So if the bar is going to be more upward, then it should be considered positive deviation bar. And similarly, when the bar is going to be downwards, the below zero line, so then it should be considered as negative deviation bar. So this is another example for that. This is another example of the deviation bar. And next one is stem and leaf diagram is another way of representing that. So the stem and leaf is a quick way to organize the large amount of data. And the special table where the data value is going to be splitted into leaves in the form of stems. So usually the last digits will be the leaves, and other digits that should be considered as the stem. And this term is going to be used as group discourse, and each leaves indicates the course within the group. So if I'm going to consider a set of values like this, so if the data is going to be fall below the baseline of this, then it should be negative deviation bar, then what we call it as the stem and leaf. So similarly, they should be considered as the stem, and then these are the leaves. Suppose 66, 67, 68, 68, and 70, 72, 72, 74, 75, 78, 79 lines. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.